Okay, today we are starting on angle relationships. We have a bunch of vocabulary. We should be review vocabulary. However, you probably should at least have something written down for each of them in case you forget. I'm going to go over these fairly quickly, so you may need to look some of them up in the math dictionary that's linked on the lesson page. So an angle is a figure formed by two rays or sides with a common endpoint called the vertex. A right angle is an angle that measures exactly 90 degrees. An acute angle is an angle that measures greater than 0 but less than 90. An obtuse angle is an angle that measures greater than 90 degrees and less than 180 degrees. A straight angle is an angle that measures 180 degrees. Complementary angles are two angles. When you add them up, they equal exactly 90 degrees. Supplementary angles are two angles that when you add them together equal exactly 180 degrees. Adjacent angles have a common vertex and a common side, but no common interior points. A vertical angle is a pair of congruent non-adjacent angles formed by two intersecting lines. And congruent angles are angles that have the same measure. So, a lot of words there in a minute. You need to know those words because I'm going to be using those words in the next section, so make sure you have something written down about those or are familiar with those, so when I say complementary or adjacent in the examples, you aren't like, what the heck is she talking about? So we are going to use the diagram to name each figure. Acute angles are less than 90 degrees. Okay, this is fairly simple because you can look on your diagram and say, well, there's a 47 degree angle there and there's a 43 degree angle there. Those have to be my acute angles. So we have angle TQP. You always start with a point on a side, then your vertex, and then the point on the other side. Your vertex is always in the middle. And for the next, we have S, Q, and R. So we either start with S or R, Q goes in the middle, and then R or S goes second. The obtuse angles are a little bit more difficult, okay? Because you look on there and there's no angles that are more than 90 degrees. We have one that's exactly 90, but that is not obtuse. That's a right angle. So what we have to do is we have to take two adjacent angles and make them into one angle. So, for example, SQP, okay, we took this angle and put them together, those adjacent angles together, and now we're looking at it as one whole angle. And when we add 90 plus 43, we get 133 degrees. So we know that SQP is a obtuse angle because it measures 133 degrees when we add the two adjacent angles together. So angle SQP. Now we need to see if we can find another obtuse angle. And we can do the same thing. We can just go this way, okay? And we can take this angle, and we can take those adjacent angles, because that's what they are, because they share this side, and we can add them together, and we get 137. 137 is an obtuse angle. So because we get 137, when we add those adjacent angles together, angle RQT is also an obtuse angle. Now we're going to look at complementary angles. Complementary angles are a pair of angles that measure 90 degrees exactly. It's not the 90 degree angle because it's a pair, and a pair means two. So we have to find two angles that measure to 90 degrees. They do not have to be adjacent, they can be separate. So 47 and 43. When you add 43 and 47, you get 90 degrees. So we can say those are a pair of complementary angles. So we have angle TQP, because the vertex always go in the middle, and RQS, side, vertex, side. Okay, now we have a pair of supplementary angles. Supplementary angles add up to 180 degrees. All right, so it is only two angles because it's a pair. A pair is two. So looking at this, we have to do what we did with our obtuse angles, and we have to create two angles out of those three. Because it lies on a straight line, we know that we're going to have supplementary angles. So we're going to take this here, and we're going to look at it as one angle. We're going to add these together, and we're going to get 137. So we have a 137 degree angle and a 43 degree angle. TQP is 43, and TQR is 137. And when you add those together, you get 180. So we're going to do side, vertex, side, and then we also will do side T, vertex Q, side R. Now we need to find a second pair of supplementary angles. So we're going to do the same thing we did with the obtuse angle again. And we're going to look at this angle, these two angles here, these adjacent ones, and we're going to put them together to create one angle. 90 plus 43 is 133. So angle SQP is 133 plus angle SQR, which is 47, equals 180 degrees. So we know they are supplementary. So we take side S, vertex Q, side P, and side S, vertex Q, side R. Okay? Use the diagram to find each angle measure. These are, right here, vertical angles. And vertical angles are a pair of congruent non-adjacent angles formed by two intersecting lines. And when you have those, the opposite angles are equal to each other. Okay, so those are equal, and 2 and 4 are equal to each other. Okay? Adjacent angles equal 180 because they are formed by intersecting lines. So on vertical angles, adjacent equal 180. All right? So if we know that the measure of angle 1, which is right here, is 37 degrees, we want to find out that measure of angle 2. Now those are adjacent angles because they share a side. And we just said that adjacent angles, when we have vertical angles, are measured to be 180 degrees because they fall in a straight line. So we have the measure of angle 1 plus the measure of angle 2. They have to equal 180 degrees. Okay? Angles 2 and 3, because they lie on a straight line, are supplementary. I don't know why that's important, because to me it doesn't seem to be. So we take the measure of angle 1, which is 37, plus the measure of angle 2, and we get 180. So we substitute 37 degrees, and now we solve for the measure of angle 2, which is considered the variable in this case. So 37 is being added, so we subtract 37 from both sides, and the measure of angle 2 is 143. Now if I know that angle 2 is 143, 3 is going to be 37 because it's opposite angle 1, and 4 is going to be 143 because it is opposite of angle 2. So if you know one measure, you can find all of the measures with vertical angles. And last example for this lesson, a traffic engineer designed a section of roadway where 3 streets intersect. Based on the diagram, what is the measure of angle DBE? Okay, so we are looking for, I'm going to put it in green, DBE. Now that right angle sign includes the measure DBC. Okay, so if we know, first of all, we are going to find the measure of CBD. Okay, so how we do that is we see if there are intersecting lines that create vertical angles, and there are. We have this line here and this line here. Those are intersecting lines. They create vertical angles. Okay? So because of that, we know that if angle ABF is 26, that CBD also has to be 26 degrees. So we know that CBD is congruent to angle ABF because of the vertical angles. So if the angle of ABF is 26, the measure of CBD has to be 26 degrees. So, I'm sorry, has to equal, they put so many extra stuff in here. The measure of angle CBD has to equal the measure of ABF, which is 26 degrees. Okay? So, we know this because vertical angles are congruent. And then we know this because congruent angles have the same measure. So 26 degrees is what angle CBD equals. Now we need to find the measure of DBE, which is what the question told us to find anyways. Now in the beginning I stated that this right angle sign right here applied to BCD plus DBE. Okay? So we know the angles are complementary because if you add those two together you would get 90 degrees because it shows a 90-degree angle. So we're going to take the measure of CBD plus the measure of DBE and we're going to get 90 degrees. Okay? Now we know CBD from above is 26 degrees. So we're going to substitute 26 degrees for CBD. And then we're going to solve for angle DBE. So we're going to subtract both. 26 from both sides. So we're going to subtract 26. That's going to get angle DBE alone. And this is incorrect. This should be DBE. I got confused for a second. And 90 minus 26 is 64 degrees. So DBE measures 64 degrees. Okay? Do 1 and 2, and then get started on your homework.